So, in this second session of today's webinar, we're really looking at understanding the intersection of open educational practice, but we're also exploring the evolution of climate science and climate literacy, helping develop your skills for finding and adapting resources, and then using those resources to explore those guiding questions that help your students and those that you work with really look at inquiry.
So I'm gonna jump in for the next few slides. Thanks, Joanna, for giving us the overview. And the reason we're having this webinar series and a big part of why Clean exists and one of the goals of Open OER is to respond to this ask from Americans on having climate change taught in schools across the board. Americans want climate change to be taught. The lowest states across the country have about 65% of folks who would like it to be taught, going all the way up to around 85%. And if you were here last week, you probably saw Anthony Lacerowitz talk about this. And if not, I'd encourage you to check out the recording. But there is a strong mandate for teaching climate change in the United States. And that has resulted in 49 out of 50 states either adopting or adapting the next generation science standards, which means that 49 out of 50 states have climate change in their state standards and expect schools to teach it. With this mandate and the increased demand for climate education, CLEAN was created in 2010 after the first climate literacy principles were published in 2009 to provide educators what they need to engage with climate literacy in their classrooms. We have a resource collection, teaching guidance, and a network that you can join that I'll talk a little bit more about later in the webinar. But probably the biggest place people come on our website is to the resource collection. And I'm going to turn it over to Joanna to talk a little bit about how OER approaches resources.
Thank you so much, Patrick. Patrick, would you actually mind popping back to the cover slide, and then I think there's the introduction slide. We've got folks kind of joining, and I want to make sure that everyone kind of knows who's talking and where we are. So I'm Joanna Scamitzi, and I'm with ISKME. And so at ISKME, we support OER Commons. It's a global digital library that we created to help educators find openly licensed resources. And so one of the reasons that this is so important for climate literacy and for science is because we know that educators want to be able to find high quality resources, but that they need to adapt them for their own situation. So hopefully you have gotten some emails from me, and it's been a nice balance of helpful versus pesty. And I'm really glad to be partnering with Clean as this on this webinar series. So Patrick, did you just want to say a quick hello for folks who are just joining and maybe didn't see that part of the slide deck?
Sure, I'm Patrick Chandler with the Climate Literacy and Energy Awareness Network. And we also have Raj Pandya, who will be talking in just a couple minutes.
Thanks. So as you prepared for coming to this webinar, you might have had a chance to look at a resource. And so what I want to do is just launch a quick poll and see what you might have thought as you looked at this resource. Which of these questions crossed your mind as you took a look at this food and climate change resource that was from MIT? Awesome. Give folks about one more minute to finish selecting all the questions that you might have thought of as you were taking a glance at it. So just real quickly, the reason that we want to do this is one of the goals of the webinar is to help you have time to dig deeper into resources, but also to have you thinking really critically about the climate literacy resources that you're looking at. So one of the things that we wanted to share is that during this series, our goal is to help make it easier for you to find climate resources that are really high quality. And so this resource itself is part of the Clean collection, but it might have been hard for folks to find if they don't know to go to Clean. So we're excited that OER Commons is a spot that a lot of educators might already be at. And so they might be searching for resources and might use their keywords and stumble across it. But you, after today, will be one of the leaders that we hope will share with your colleagues the hub that's on OER Commons, the collections of resources. The next bullet point is actually the question, what can I do with this resource? Which we'll talk about. What is the licensing? Are you allowed to remix it? Can you put it in your learning management system? And then we really want you thinking critically about how do you know if your students will actually learn from it? So on the next slide, we will make sure that by the end of today, by the end of this series, that you feel really comfortable finding that climate education hub. In just a few minutes after our guest speaker speaks, we're going to share with you that resource that holds the published slide deck and all of the links. But we really want you to have some time to dig deep into the content. So at the next section, we'll really dig it back into that collection, but we want to make sure that you know that that's coming. And these are resources that you have the right to use, to modify, to share. Let's see, I think there might be one more slide. And so that is the key about open licensing, open education, and it's such a great partnership with science and researchers who their goal is to make science participatory, to make education participatory, to make it a community opportunity. And that's why we're so excited that so many people have chosen to put an open license on their resource so that folks can remix it to make it local, so that if you go to the search for hiking and climbing, that you can make your resources specifically reference that and use that as an anchor for your students. So that is why OER Commons is here, to help you find resources that you can modify. So we're so excited. Thanks. Oh, and you'll be part of our group from now until forever. So again, we'll hit this group again at the end. So thanks so much for those of you who've already joined the group and started participating in the discussion boards.
Great. And I'm just going to take about 2 minutes to set the stage a little bit here on where we're at with this webinar series and how we're thinking about addressing climate literacy. This is the most recent definition of climate literacy, came out last year. And I want to highlight that the yellow is how this definition has changed since 2009. And to me, what it shows is a shift from a focus on awareness of climate change to providing agency on climate change and helping establish a space where learners are expected not just to know about it, but what to do with that information. That switch is reflected in the climate literacy principle updates that were published last year to go with the fifth National Climate Assessment. Those are under review, but what we still have is the 2009 climate literacy principles, which are shown here, and the 2024 climate literacy principles, though under review, really showed this transition well. Basically, we have moved from in 2009 from a systems focus and an awareness focus of climate change to a problem focus and an agency focus. And where we're at in climate education right now, instead of asking that students know everything about the system, we're hoping they know that climate change is caused by us burning things, creating greenhouse gas, and warming the planet. And with that problem focus, switching to an agency focus of students should be able to understand adaptation, mitigation, and components of climate action. So we've really seen a huge shift in the last 10 or 15 years in climate education. And Raj is going to talk about that shift from the science perspective. We're going to switch into that mode here. Um, and I want to introduce our amazing guest speaker, Raj Pandya, who is now at Arizona State University and was previously the director of Thriving Earth, the American Geophysical Union. And without further ado, Raj, please further introduce yourself if you'd like. But we are honored to have you here. One more quick note, I'm sorry, is that please ask your questions in the chat while Raj is speaking. My colleague Gina will be monitoring those questions, and we'll make sure to get to them, get to as many of them as possible. All right, without further ado, to you, Raj.
Thanks very much. Thank you so much for letting me be here today. Thanks to everybody on this webinar for the important work you do in the space of education. Education is a group and community project, so for being part of that education community in a big way. And I'm really excited to think maybe or hopeful that I can offer something a little bit useful as you do the work you do that is so important. I'm going to try to organize this talk around four kind of big pillars, and I'll try to pause after each pillar so that we can have a little bit of Q&A instead of waiting till the end. A lot of what I'm going to say is what Patrick said. I'm just going to say it more slowly, I guess. I'll start by talking a little bit about the nature of science. I think it's really important to think about what science is when we're thinking about how we want people to be able to use it to make decisions together and individually about the way they want to be in the world. Then I'll talk a little bit about the climate science I learned as a climate scientist, what I'm calling climate science 1.0, which was really focused on kind of physical climate systems. And then I'll talk a little bit about climate science 2.0, which is really where we start to move beyond the physical system and start to think about convergence, all of the different disciplines that contribute to how we understand the world and how we understand our relationship with it, civics, how we make decisions about that, how science is part of those decision processes or can be, and relationship to nature. Originally, I titled that Solutions, but the more I think about it, the less I think it's about trying to solve the climate problem and more about reimagining our relationship with the planet in ways that are healthier and more positive, not just for the planet, but for ourselves, and doing it in a way that centers sort of everybody's right to live productively, whether they're human or not. And then finally, I just want to end with a note of appreciation and support for all of the work that everybody's doing, work that maybe has always been a little bit hard and at times gets even more hard. So with that, let's talk a little bit about the nature of science. If we could go to the next slide. I think nature of science, I remember when I first started teaching college, I went to somebody I really admired and said, what's the most important thing I can teach in my meteorology class? Like, what would it be about lapse rate? Would it be about radiative balance? And he's like, it would be about science. The students are going to take one science class. If you teach them about science and how it works, they'll be able to use that to do all kinds of things in their life. If you teach them about meteorology, they're just going to be able to do meteorology. And so in that spirit, knowing about the nature of science, I think, gives people tools to help evaluate, apply, and advance science. It helps tackle contentious issues, issues like evolution, like vaccination, like climate change, right? And so I think there's maybe three things to really think about when we think about the nature of science. And by the way, I got to be a scientist without ever learning about the nature of science. Sort of ironic. Um, Science is a way of knowing about the world. It's one of many ways of knowing about the world. It's good for some things. It's not great for other things. We'll talk about that in a little bit. But it's a way of knowing about the world that prioritizes testable or falsifiable explanations, explanations that you can actually go out and test. A falsifiable explanation or a testable explanation is something like the world is round, or the Earth is the center of the solar system. You can actually make observations. You can take tests that help you figure out if that's true or not. An unfalsifiable explanation, a non-scientific kind of explanation, would be something like we all live in the matrix. Descartes had slightly different words for it, but was that idea. You can't really go out and test that. There's no way to test it because any test you do could just be a product of the matrix itself, right? So testable and falsifiable explanation, that takes us to the second point, which is science is about empirical evidence, about things we can observe, things we can measure, things we can sense. Maybe not directly, Maybe we can't touch them, but we can build instruments that help us experiencing them. And the last thing is that those experiences can be shared, that there's an ability to repeat that we can do a test again and again and get pretty much the same answer over and over again. And it's those three factors, I think, that really contribute to the way science works and is about the nature of science. If we go to the next slide, this is a picture of the sun. And this little dot that you can sort of see, thank you, yeah, that's Mercury. That's actually Mercury moving across the surface of the sun, or well, not the image of Mercury moving in front of the sun. Mercury was a problem. Newton's laws of gravity couldn't account for the precession or the changes in the orbit of Mercury. We tried all kinds of things to make them work. We tried different kinds of, accounting for different distribution of other planets. Nothing worked. The other thing about Newton's law is it explained that this thing called gravity would do this thing and it would work in this way, but it didn't say what gravity was. General relativity, Einstein's theory of general relativity came along, and it actually predicted the change in the orbit of Mercury in a way that Newton's laws couldn't. It also gave an explanation for what gravity was. It said it was a warp in the space-time continuum. I know that's a little abstract. Um, and it predicted a bunch of things that we didn't know about until then. It predicted black holes. It predicted that time would actually slow down in satellites that are orbiting the Earth, which turns out to be super important to our GPS locations. If we didn't know that, we would get all our locations wrong. Um, it also predicted something called gravitational waves. And all of those predictions made by that theory of general relativity were later borne out by observations and facts, and tests. And so if we go to the next slide, there's a cool thing that's happening there. We're starting to see the difference between laws and theories. Laws describe the way the world works. Theories explain why it works that way. And as we saw in the case of general relativity, a theory can explain multiple laws and set the stage for new discoveries. A theory is sort of like the best thing going in science. It's like way better than a law. I think a lot of people in popular culture think about theories as like that's just your theory, but in science, like theory is the thing, right? So, so that's, I think, an important thing to help people understand that when we have a theory like the theory of climate change, it's something that accounts for multiple strands of evidence and puts them together in good ways. The other thing that's interesting about this Einstein story is he didn't think of the theory of of special relativity. He started with special and then he went to general. He didn't think of that by following the scientific method. He was having daydreams about what it would be like to be on a train that kept moving faster and faster. And that's, I think, an important thing for people to understand too, is scientists don't use the scientific method. Scientists use many different methods. There's lots of ways of doing science, and science is a creative, energetic, vibrant process of making mistakes, of trial and error, of creativity and agency, and none of that's captured with this notion of the scientific method, right? The other thing about science is it gets better with time and trial. It isn't perfect. I think sometimes people imagine or they learn science as a bunch of facts that were discovered a long time ago instead of this process of constantly refining our knowledge. Most of the time, those refinements are on the edges. We get a little bit better and a little bit better. Occasionally, something comes along that just completely upsets the apple cart and reinterprets everything in a better way. Continental drift was a great example of that. Actually happened in the 60s. There was a scientific revolution in the 60s. Um, and then all of that to me brings us to a point that there's worth being somewhat humble about science, right? Science is a way of knowing, but it's not the only way of knowing. It's great for predicting things about the way the world might interact. It's not great for doing ethical, moral, civil or political decision making. It needs to be part of those things, because science can help it. It also needs to be guided by ethical, moral, civic, and political decision making. And it's influenced by all of that. So I think if it's okay, I might stop there for just a second and see if there's any questions about the nature of science. And I promise we're going to get to climate science next, but I think this nature of science is important for helping us communicate and understand climate science. So what questions do folks have now? It's also my theory that if I stop more often, it's more interesting than if I just keep rambling. So,
Gina, were there any questions that came up in the chat so far?
Ooh, I could answer Deb's question if that's cool.
Yeah, sounds great.
All right, so Deb asked, how does science vary across science across cultures vary, and what is the same? Science is a human activity done by a bunch of humans, so there are going to be cultural constructs inside of science. There are going to be cultural things inside of science. Yeah, there's opportunities for culture to introduce bias. I think that gives us a reason for thinking about having multiple different perspectives and different cultures contributing to science. Some of the things that try to be the same across all of science are appealing to that evidence, testable hypotheses, those three big things about science. But the ways in which we do science, the ways in which we talk about science probably do vary. Um,
Sorry,
maybe,
was having issues unmuting. Um,
okay. Hey, Gina.
that that was the only question, but I just want to acknowledge that everyone in here is really resonating with what you're saying. So this is great so far.
Cool. Well, thanks
Keep
for letting
going.
me do that little bit of background. I think it's important. So let's jump into climate science 1.0. This is what I learned in graduate school, sort of basic physics. Well, actually, it's not even what I learned in graduate school. And Deb, it kind of attaches to your question about science as a cultural activity. Um, Here's the big thing, right? Human activity is causing the planet to warm. Hopefully, that's not a newsflash to anybody on this call, right? We have basic physics that shows us this is happening. We have observational evidence, and we have lots and lots of impacts because of that. So I'm going to talk about each of those things. Let's talk about the basic physics first. I learned when I was in graduate school that some guy named Jeff Tyndall, yeah, next slide, please. Sorry. I learned that when I was in graduate school, Jeff Tyndall was the first person to talk about the greenhouse effect. Turns out he wasn't. Turns out it was a woman named Eunice Foote who had done experiments, and published them, and then later kind of left science to do some other things with her life, like raise kids. But she had done some early experiments where she measured the temperature in different kinds of atmosphere, in different kinds of glass vials filled with different kinds of gases, and noticed that that glass vials filled with carbon dioxide had a higher temperature. And she hypothesized for the first time in print that that might also occur in the atmosphere. And if it did, atmospheres with more CO2 would have more energy, would have higher temperatures than atmospheres without. So that's the first real indication of climate change. That was back in the 1800s. Her work was sort of under the radar for a long time, recently rediscovered and republicized, and she's now getting her appropriate place in science. I can't help but wonder if it was easier to dismiss that work because she didn't fit the conception at the time of what a scientist was or should be or looked like, which points to that point about sort of why it's important to why cultural why the culture can influence how the culture can influence science in ways that are both good and something to watch out for. Next slide, please. So it turns out this is kind of what we think is going on. These are the latest sort of observations. This slide is actually one of the only images that I'm taking from IPCC. All the rest are from NCA5. IPCC is the Intergovernmental Panel on Climate Change. It's the international group that does that pulls together all of the latest research around climate and tries to publish it in a coherent way. We have an American group that does the same thing. It's called the and and
The
I'm blanking on
National
the
Climate Assessment. Oh, and
yes, you got it.
done by the
I
United States Global Change Research Program.
thank
Just
you very much.
sorry to jump.
No, that's really helpful. So anyway, basic story here, which is kind of cool. Sunlight comes into the top of the atmosphere. It's visible light. It mostly goes through the atmosphere. Turns out molecules in the air don't interact much with sunlight. So it gets to the ground. A lot of it's absorbed at the ground. A little bit gets reflected off the ground. A little bit gets reflected off of clouds. The ground itself heats up and it transfers some of the heat that it absorbed from that sunlight back into the atmosphere. It does that in a couple of ways. It does that through evaporating water. It does that through what's called sensible heat, which is just sort of if you put your hand close to something hot, you will feel convection. Air will move heat to your hand. It's that process in the atmosphere. But the bulk of it is actually transferred by radiation. The Earth heats up, it emits a little bit of infrared radiation. Infrared radiation is a different kind of radiation, different flavor of radiation than the visible light that comes in. And so that flavor of radiation is a flavor that CO2 molecules can absorb. So they absorb that and then they re-emit it. They emit some of it back up to space. They emit the rest back down to the ground. And because they're there doing that emission, they make things a little bit hotter, right? It turns out, again, this point that theories are things that pull together multiple pieces of evidence. We now understand why CO2 does this, and it's because of quantum mechanics, or we explain it in terms of quantum mechanics. It turns out molecules don't just absorb any light that comes at them. They can only absorb light that matches the characteristics of their resonance, the vibrational patterns that they like to do, that they're structured to do. CO2 can vibrate in ways that absorb infrared, but it can't vibrate in ways that absorb visible, because visible light is a different frequency. So that's why the greenhouse effect works the way it does. That's why CO2 can absorb this energy and then re-emit it backwards and forwards. Is everybody with me so far? Sorry, I geek out on this stuff. Next slide, please. We can test this idea that different atmospheres should have different that will result in different temperatures by looking at other planets. Venus has a totally different atmospheric composition. We can predict what its temperature would be with and without that atmosphere, and it kind of matches what we observe. So that's cool. Piece of evidence in support of this. Next slide. Another piece of evidence, we can look back through time. We can drill cores into the ice and we can pull out old atmospheres and we can look at those old atmospheres. We can look at pollen records from the past and we can understand what that might have meant about average temperatures. And we can correlate CO2 and temperature backwards through time. Now, it is true that correlation isn't causation. So this doesn't prove that CO2 causes climate change. But if that relationship between CO2 and temperature is accurate, we would expect it to be visible in the record, and it is. So it's another piece of evidence that supports this idea that the way we understand the climate system is pretty much right. If you will, the theory of climate is roughly right. Next slide. The other thing we can do is we can just look at recent observations, and there's a bunch here. The ones I want to highlight are the carbon dioxide curve. Carbon dioxide has gone up. So if Eunice was right, we should see temperature go up. Whoa, temperature goes up. Yay, Eunice, right? But we can also know that this carbon is new carbon. We can look at the isotopic signature of that carbon, and we can know that it didn't come from recent plants. It came from plants that have been dead for a long, long time. So we know it's from fossil fuels. We can look at oceans, because if carbon dioxide in the air is going up, ocean pH should go down. It does. We can look at ocean heat content to see some of that energy being absorbed by the heat. Remember I told you those CO2 molecules absorb energy and re-emit it? Well, if they're doing that, then the upper atmosphere, the upper part of the atmosphere should be a little bit colder because they're emitting more energy. The lower part of the atmosphere should be a little warmer. Whoa, that matches observations. And then this slide also starts to show some of the impacts of climate. It isn't just about the temperature warming. It's also about sea level starting to rise here. It's about glaciers starting to melt. It's about ice sheets starting to melt. It's about sea ice decreasing in extent. So you can start to see some of the impacts of climate change throughout different parts of the physical system. And what we understand about the way these systems work all matches what we observe, or I should put it the other way around. All the observations confirm or provide additional evidence for what we observe. Next slide, please. I think it's also important to understand that climate isn't just an impact on temperature or on physical systems. And a good way for me to sort of get a picture of the impact is to look at NCA 5 and just look at the chapter headings, right? The chapter headings are water, energy, land, forests, ecosystems, coasts, oceans, agriculture. All of these things are influenced by climate. Social systems and justice are influenced by climate. National security is influenced by climate, right? You're not going to get away from this influence, and you're not going to get away from it geographically either. And the last thing you can see in this table of contents, it's amazing how much you can learn from a table of contents. There's actually a Kurt Vonnegut novel where there's somebody whose profession is creating indices, and they are indexes. And they talk about how you can learn a lot about an author by creating their index. Anyway, compound events. we're not just seeing climate change impacting one or two things. We're seeing climate change impact a sequence of things. So you might have a hurricane that was more likely to have happened because of the changing climate. That leads uh, to landslides, or you might see increased warming and changes in precipitation leading to wildfires. So we're starting to see cascading events that can be linked to the impact of climate change. Next slide. Just one sort of little comment. I think there's a tendency to argue that one of the ways that we can convince people that climate change is real is by talking about the consensus opinion of scientists. You've probably all seen the little cartoon that's like 98% of scientists say that climate is real. 1% is sitting over here being a dork. Um, that's not a great argument. I think it can land on people as an appeal to authority. And right now, first of all, science doesn't work by appeal to authority, it works by appeal to evidence. And right now, people aren't super into authority and expertise anyway. So I'm not sure that's going to convince anybody who's a skeptic. What I would say instead is emphasize the nature of science, that what we have is lots of different tests of lots of different pieces of this comprehensive theory of climate. Lots of that evidence is being rechecked and rechecked by different people with different motivations and different backgrounds and different perspectives. Some of them are actively trying to disprove each other. And yet, all of that process seems to confirm again and again that the things we're seeing are real and are because of this physical climate system. So let's pause there and see if there's any questions.
Dina, do you want to highlight any this round?
Sorry, I'm just looking. There was some discussion about which Vonnegut book you mentioned, which it sounds like it was Cat's Cradle specifically.
I think that's right. It's the one, I remember it talks a lot about Indiana folks. So I read a lot of Kurt Vonnegut when I was a kid. I don't remember which one, I'm sorry. But okay, Cat Cradle, perfect.
Yes. And then Frank asked, he said, I'd love to know where this slide on increasing and de decreasing climate trends came from.
All of the slides,
Um,
unless I say otherwise, are from NCA 5. There's actually, so I'm pretty sure it came from there.
okay. I see he was copying a question from someone else. So yep, everything
Got it.
came from NCA 5 website. But that's yeah, that's that.
Cool. Okay. Oh, Joanna asked a nice question. She said, is that two-time amount specific to the Earth's atmosphere? Um, no, it's different for different atmospheres, and it depends on what the composition of the atmosphere is. So some atmospheres absorb more visible light because they're made of different kinds of gases than our atmosphere. Some absorb less visible light. Um, if we lived at the bottom of an ocean, that wouldn't quite be an atmosphere, but water absorbs a lot of visible light. So at the bottom of the sun, you wouldn't have anything like that kind of radiation hitting the ground. So completely depends on which planet you're on and the composition of that atmosphere. All right. Some cool things, like one of the things that is maybe sometimes a strategic mistake that climate scientists make is they talk about what they don't know instead of what they do know. We do that because we get excited about what we don't know. And so I want to talk a little bit about what we don't know yet, but I want to preface this by saying all of the things we don't know have a small impact on the climate system compared to what we do know. So we're in a situation where we're trying to get the details right, and there are some things we're struggling with, but it doesn't change the big picture. So one of the things we don't know is clouds. Clouds are complicated. If you want to think about a cloud, you have to think about everything from the scale of a tiny little molecule and whether it's going to attract water to it and start to condense to become a cloud drop, all the way up to something that's extending across half a hemisphere, right? And that's a challenging thing to think about. So the role that clouds will play in the climate system, whether we'll have more of them or less of them, whether they'll be high clouds or low clouds, those are all things we're still trying to figure out. And they all have impact on what the ultimate effect of climate change will be. Again, not enough to make us, we don't have to worry about climate change kind of impact, but just is it going to be a little bit worse or a little bit more? Ice, how fast the ice melts changes how much sunlight gets reflected by the surface, changes how much energy gets absorbed by the surface, changes how much gets re-radiated. So it has an impact on the climate system. Ocean currents, how fast they change, what they change. Permafrost, how fast the permafrost melts and how much methane is emitted. We haven't talked about methane much, but it's another greenhouse gas that's important to think about. All of those influence the climate. Um, those are it, the biggest uncertainty in the climate system actually is us. It's what we decide to do about it as a species, as a collective, right? How do we deal with climate change as an uncertainty? That's often called adaptation or resilience. How do we prevent it from getting worse? How do we keep CO2? How do we cut down on the CO2 we emit or the methane, which is another greenhouse gas? That's often called mitigation. Those are actually bigger pieces of uncertainty than any of the physical uncertainty. And that leads me into the next part of the talk, which is climate science 2.0. So if we could go to the next slide. Oh, this is just making that point that the uncertainty about what we know is small compared to the change we're likely to experience. And we're getting better. Remember I said science is about getting better? These little uncertainty bars are getting smaller and smaller as we go from the earliest report on climate change, which was called the Charney Report, to the latest report on climate change, AR5, and ultimately AR6, or um, uh, uh, I can't remember what AR stands for. Um, uh, doesn't matter. It's a sequence of reports that are released as part of the National Climate Assessment. So next slide, please. Climate Science 2.0. Convergence and complexity. Humans and human decision-making, relationships to nature. It's not enough to just understand the physical system. We have to understand its relationship to the social system and the social system's relationship to it. We have to actually make decisions based on this. That means we have to think about how climate science and climate knowledge interacts with all kinds of other things as part of a decision-making process. And ultimately, we have to think about our relationship to nature, and how we want to be in relationship to nature. And what I think the climate change reveals is that our relationship to nature hasn't fully accounted for all of the coupling between human activities and natural systems. And so as we learn more about those couplings, as we learn more about the ways in which we're intertwined, we need to start incorporating that knowledge into the way in which we live and the way in which we work and the way in which we interact with each other and with the planet. So let's talk about convergence and complexity. And I will warn you before we go to this next slide that I love complicated figures. So here's a complicated figure. This was put together by a guy named Bretherton. It's called the Bretherton diagram, and he tried to outline all of the things that went into the physical system. And what's cool about it is it's complicated, but but what's also kind of weird about it is human activities are this little tiny box over here, right? So if you look at the next slide, we can start to blow up what those human activities actually look like. All these things are part of that little tiny box. And in some ways, I think that little tiny box is actually way more interesting than all of those physical systems. I shouldn't say that. I love physics. I love physical systems. But we have to think about emissions, we have to think about policy, we have to think about collective action, individual actions, we have to think about the way people think about risk, how we process distant risk versus near risk, how we prioritize different risks. We have to think about how we make decisions. I think there's some argument to be made that we have governance structures that are equipped for a kind of decision making that isn't really well suited to the kinds of large scale and long-term decisions that we're trying to make. And when it comes to climate, we've got social norms, we've got culture. All of that is a huge part of what Climate Science 2.0 is starting to think about. Not just how the physical system works, but how we live in relationship to that physical system, how we make decisions in relationship to that physical system. And if we go to the next slide, we're even starting to realize that something as quote unquote objective as climate has huge social implications. These are maps that show how land temperature is related to income. Now, there's no physical reason land temperature should be related to income, right? So what's happening here is we're starting to see the social determinants of the impacts of climate change that are mediated by decisions outside of the climate regime that influence the way in which we live and build our cities. So it turns out that neighborhoods with more wealth tend to have more trees, and those trees tend to produce a cooler environment than neighborhoods with less wealth. Neighborhoods with less wealth tend to have higher density, tend to have more hard infrastructure like concrete, things that don't cool off as night. Maybe they also have less access to cooling technologies. They might have less open space. All of those things influence the exposure to climate change. So climate change, yeah, redlining, Tiffany, exactly. Climate change is not just a physical science issue, it's a social issue. It's a justice issue. And we can't solve for climate without also attending to issues of justice. So we need to be thinking about that as part of our attack on climate change. Next slide. Um, I'm going to talk about three kinds of ways of thinking about our relationship with the planet. The first is the technological. And there's good news here. There are things we can do to reduce emissions. There are things we can do to uptake carbon from the atmosphere. Those are what I'm calling technological solutions. We can improve energy efficiency. It's already true that new solar plants are cheaper than any other form of energy. So we're getting to a place where it makes economic sense to sort of invest in renewable energies. Although you could also argue that that idea of economic sense is a little bit narrow because economics doesn't include sort of the the costs of climate degradation in its calculations, and that's a shortcoming or an incompleteness about our current economic models. There's also something we can start to do to take up carbon. That's a little bit more complicated because some of those involve really intervening in the climate system in ways that probably need a bit more need more social technology around how we make decisions together. But these are kind of the technological kinds of ways we can tackle climate change. Next slide. There's also, this is that slide that I wanted to show, just showing how those technological solutions are actually in some ways encouraging the fact that solar is expected to increase pretty substantially. Coal, the dirtiest kind of most carbon emissive form of energy generation, is expected to decrease pretty substantially. Next slide. Let's move into something called natural solutions, right? The cool thing about nature-based solutions, right, is they do many things well, right? So things like Oyster Bay restoration doesn't just provide protection from climate change, it can provide food, it provides a place of people can go to experience nature and be in nature. It does some habitat restoration, it provides some flood management. Urban parks can actually help decrease that heat effect that we saw earlier. And what's cool about these nature-based solutions is they also start to point towards the next kind of innovation that we need, which is an innovation in the way we think about our relationship to nature. So if we could go to the next slide. Maybe innovation isn't even the right word because there are ways of thinking about the relationship to nature that go back millennia and could provide some guidance for how we move forward. I have a friend who likes to say that you behave very differently towards the world when you think about natural relatives instead of natural resources. And so recognizing that human lives are intertwined with natural lives, that humans aren't exceptional on the planet, but are part of the planet, that we have a contribution to make to the planet, and a responsibility that goes with our presence on the planet. Those kinds of social and cultural innovations can help us to solve or to manage our relationship with the planet in ways that mitigates the impact of climate change, perhaps even more effectively than some of the technological solutions that we talked about earlier. I think the idea I'd like to leave you with is that we can't solve climate alone. We can't solve it without learning to work together, that we can't solve it without learning to work together better, that social justice and environmental justice are deeply entwined with climate justice and climate solutions, And we're really involved in a project now of reimagining our relationship with each other and with our planet in lots of different ways. And there's very cool models of what this looks like. There's things like participatory dialogues. There's ways of teaching that help accomplish this, very agentic kinds of pedagogy that gets students out in nature, gets students out of the classroom and involved in local politics in ways that are trying to build consensus. I think I just want to close with a recognition that the work of education is hard. It's always been hard. Um, and I think climate education can be a particularly hard place to work because it does bring up some pretty big feelings. And it can point towards some political divides that can be difficult to navigate. A couple of things that I have found helpful: um, compassion, compassion for people who disagree with you, compassion for people who aren't as concerned about climate, maybe not because they're ignorant or uh, or trying to be obstructionist, but because they have 1,000 other things on their plate that they're worried about. Listening. One of the most cool things I've heard about is that you can help people change their mind about things, not by trying to change their mind, just by asking them to talk about how and why they think the way they do. And often people in that process will start to question their own assumptions as long and the point there isn't that we're trying to get them to change their mind. The point is we're trying to extend them the courtesy of being listened to. Um, Often you can begin a conversation about climate change not by talking about climate change, but asking people what they've seen and noticed in the environments they live in and the environments that are important to them. We don't have to all agree that climate change is a problem to do things that help prevent climate change, that help make it less worse. You can protect your neighborhood from flooding, and you can reduce your dependence on fossil fuels without caring about climate change at all. And why not embrace those things? And then finally, because this work is hard and it takes a while, and you've all been working hard already, and you're going to keep working hard, it's 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 probably worth thinking about this as a little bit more of a marathon and less of a sprint, and doing what you need to take care of yourself along the way. So with that, we can have a couple more questions, I hope, but I just really want to thank you all for the work you do and the ways in which you do it, and I hope that some of this was helpful as you think about all the work you do.
Raj, I really appreciate your talk and the care and compassion you ended with there. Um, I think we do have time for a couple questions. I do want to remind folks that after this, we're going to get into the workshop section in which we will explore resources that support educators in bringing this information to their students. So please stick around and do that work with us. Looking forward to it. But I'll turn it over to Gina to offer a couple questions.
Yeah, thanks. We had a couple of more technical questions, but
Okay.
this one that just came in from Andrea, I think is maybe most applicable to everyone here. What about issues with learners that resist the reality of science and continue to claim and believe it isn't real, nor is it a problem, even when presented with all the evidence? So those resistant audiences exist, and hear
Yeah,
what you're saying about compassion, but how do we kind of overcome that?
that's such a great question, Andrea. I have some of these folks in my own family. Uh, I think uh, two answers, neither of them completely comfortable even for myself. One is that we're not going to convince everyone, and we may not even need to convince everyone. We live in a democratic society. We so so there's, and I think probably Anthony Lazarowitz talked about this last week. There's a reachable middle. And so how do we reach that middle, and how do we start to build that consensus that's big enough to do the work we need to do? The second thing is, some of the most sustainable people in the world are being sustainable for reasons that aren't about sustainability. And so if we can tap into some of those motivations, it may be less important why people do what they do than what they do. And so maybe we can build structures and incentives that make it easy and convenient for people to make choices that are good for the planet by also making those choices good for them and good for the things they care about.
Great. One other question, this is more of a technical one. Someone asked when we were talking about clouds if you know about cloud seeding and if that's related to this at all, like what your take is on
Yeah,
that.
so I know a little bit about cloud seeding. There's two kinds of ideas around cloud seeding. One is a little bit older, and it was the notion that if we put ma- particles in the air, they would help water vapor condense more easily, and they would make rain more likely. So there were some early experiments that were trying to create conditions of rain to try to increase rain. Um, that work has largely kind of fizzled out. It isn't really done very much. Although there was a pretty notable success, I think, during the Olympics in China. I'm not positive I got this right, but there was an Olympics where there was some cloud seeding away from the Olympic venue to encourage the clouds to rain before they got to the Olympic venue, which I thought was sort of clever. Not saying it's a good idea, just clever. The second kind of cloud seeding is, I think, maybe where people are thinking a little bit as a climate change effort. We might be able to increase the formation of low clouds, which would reflect some sunlight, thick clouds, which would reflect some sunlight, and maybe provide a little bit of offset from climate change. And people talk mostly about doing this over oceans, um, and 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 that is a little bit less. Scientifically proven or scientifically demonstrable to be effective. It would take a pretty big scale of clouds. And there's all kinds of sort of um, governance, ethical, and legal and civic decision making that needs to happen for that to happen in a responsible way. And to be quite honest, I don't think we have good processes in place for making those kinds of decisions. And that scares me a little bit because not having the processes in place may not prevent somebody from making the decisions unilaterally. Um, so I don't know
Yeah,
if that helps.
that leads us like into a whole other discussion about yeah, weighing all of the options and cause and effect and all of that. But I'm gonna stop the questions there. There are a couple more, but I want to keep us moving. So thank you, Raj, for answering all those.
Of course, thank you. And to the folks, like I noticed some folks added some things in the chat that are really helpful. So there's more answering going on kind of peer to peer in the chat, which is awesome. So thank you for that.
Thank you so much, Raj. Really appreciate you being here. Feel free to stick around and add to the work and discussion as we move into the workshop section here. And if you'd like to answer any questions in the chat, Raj, we might be able to get to a couple more in that way. Um, if you do have questions, please put them in the chat, and either Raj or someone else may be able to help you out. But I'll pause on this slide for just a moment so that you do have a chance to get Raj's contact info. Be okay if folks reach out with follow-up questions?
Absolutely. I would love that.
Wonderful. Thank you. Okay. So we're going to shift back into the workshop time for the webinar, which will focus on figuring out how to find the best resources to bring to your students to explore the topics that we've gotten into today. And in order to do that, my first reference point is going to be the Fifth National Climate Assessment that Raj pulled so many of those figures from. This is really the most comprehensive report on the state of climate change in the United States at this moment. Came out in the fifth one came out in 2023. And I want to note this is a congressionally mandated report done by the United States Global Change Research Program. And it covers so much ground. As Raj pointed to, the chapters you can see here have many, many topics. Economics and social systems and justice are two new ones for this fifth assessment. But for the sake of guiding discussions that are most applicable to where you're at and the issues you may be facing. For the Climate Literacy Energy Awareness Network educator support on the National Climate Assessment, we focused on the regional chapters. And moving forward this spring, we are going to roll out regional learning hubs that'll focus on the information in those chapters. Each of the regional chapters has a set of key messages. And in the last webinar, we took some time to really explore the key messages and then consider what guiding questions would be useful to jump into with students based on the information that the key messages had to offer. This whole framing speaks to this new approach to climate literacy, which I want to touch on again here. After Raj's talk, I think coming back to this idea that we've moved from an awareness of systems approach to a problem and agency approach. And holding that in mind when you're working with students, really hitting home, it's about the burning things and the greenhouse gas that's causing warming, which is causing harm, is so important. And in this latest climate literacy rollout, splitting the adaptation and mitigation to highlight the fact that they're equally important and both need to happen at the same time is so important to bring to students. Not just saying climate action is climate action, but we need to be doing both of these things urgently. And finally, I think in this paradigm of moving to problem and action, holding this hope and urgency and justice aspects of it, especially the hope in the early years of climate communication, and still in some areas, there's this reiteration of if we cross this boundary, that's it. We're done. Or if we cross that boundary, everything's, finished and we can't come back from crossing that boundary. And I think part of moving to this hope paradigm for education is the focus that it's a spectrum. This whole climate issue, it's a spectrum, and there's never a point at which action is not impactful and will make a difference in that spectrum. And there's never a point at which inaction will not cause harm and further exacerbate the issues associated with climate change. So the boundaries are helpful to know that there are tipping points in the system, but I think with students really establishing we can always have an impact, and it's always important to focus on that, is good to hold. We're going to get into exploring resources to support the guiding questions that we established in the last webinar. And in order to do that, we're going to be doing work again in the OER Commons group. And I'm going to turn it back over to Joanna for a minute to talk about that group and how to get there.
Thanks, Patrick. Yes, I'm going to have everyone kind of open a new tab, or if you already have it open, head over to our climate literacy group. And this way you'll be set up for that individual work time. So here is our climate literacy and OER group. The link is coming right to you in the chat box. If you're not at a spot where you can, maybe have that open, that's okay. We still hope that you'll use this time to do some searching through the collection of clean resources. But we want to shout out that this collaboration group will be here forever, all through the series, but also after this. And so we really do want it to be something that you build and you share. During Dr. Pandya's speech, I had like 1,200 questions that I was like, I want to ask people about this or that. So I hope that you are feeling really energized with inquiry right now. So if you haven't yet joined the group, which I saw a lot of you doing during the webinar and tried to approve everyone, go ahead and open that group up, because what we want to do is give you work time, but also make sure that your work time produces something that we can all see and learn from. So on the next slide, we want to point out something that we have created on OER Commons, which is a look at the key messages for the Southwest. And so if you are going to be working in the we're going to take you next to that national climate assessment and have you pick your region, which hopefully you've already done. But I'm going to put that link in here. This is the NCA 5. So we want to get you set up real successfully for work time, right? So our goal is that you pick a key message and then you pick a guiding question and then you go look for the resources. So you haven't done that yet. I put the NCA 5 in the chat. So you'll want to open up that NCA 5. And then the way you get to the key messages is first by choosing your region. So again, I'm going to give you a few seconds to scroll down. There's a map towards the bottom, a geographic map of the United States, and you're going to choose your region. Once you're on the region, it'll show you the messages, and under each message is a guiding question. So hopefully you have found your way to your region and your guiding questions. So what is useful of your time today? We want you to walk away from today having found a resource that, as Patrick is showing on the screen, has been reviewed by reviewers, has a description of the resource, has the licensing on the resource. So you know if you can adapt it, you know if you can put it in your learning management system, you know if you can run copies of it or not. So we just want to ask you to, you've got that tab open with the group. Discussion number 2 is there. And we hope that what you'll do first is pick that guiding question. And then, let's see, Patrick, I'm not sure. I'm going to put the link to the clean collection in the group so that, Patrick, then you can maybe screen share and show the collection that folks can search.
I'm going to get into a
via
couple
keyword.
The OER collection and the clean resources for NZA 5 here. But yeah, in OER, I often get to the collection and clean by going into the Climate Hub, the Climate Education Hub, and finding the clean collection within it, which is under the climate content providers. And here you can search by keyword and have a number of ways to filter, including standards and all these other lovely tags.
Yep, and I'm putting that direct link into the chat box for everyone. So the work time, we're encouraging you to divide up into kind of 2 sections, about 5 minutes for finding a key message and a guiding question, and then about 10 minutes for just starting to find a resource. And we know that you would like more work time, that 60 minutes and being in person together would be really valuable. But our hope is that in the next 15 minutes, you can have picked your key message, picked a guiding question, and then use that guiding question to search the clean collection on OER Commons so that then you can find a resource and start to explore it, start to see what you notice, kind of like we talked you through at the beginning.
Okay. I want to jump in, as Joanna mentioned, the main focus here will be exploring the resources. The last session, we looked at guiding questions and created a few, explored a few. But if you weren't in the last section and you aren't quite with us here, I put the link to this Clean Educator's Guide to the National Climate Assessment in the chat. And it has those NCA regions. And if you go to a region, you can scroll down here and find the key messages associated with that region and guiding questions that we chose to explore those key messages. So if you weren't with us last time, go ahead and take a peek in here. Find a guiding question that suits you well, that you can explore through the resource exploration that we're going to do with the clean resource set in OER. We are going to abbreviate our times a little bit here, but this workshop section, we're going to check in about 5 minutes to make sure everyone has chosen a guiding question to focus on, whether you choose one from us to explore a key message or you create your own. If you could post the guiding question you choose in the discussion board to start. Then in the next section, we'll switch to exploring resources to get into those guiding questions. And finally, ask you to say a few things about the resource you found. So starting with finding that guiding question. Oh, the last thing I want to say before I'm quiet for some focused work time is if you're on your phone or you're in a space where you just can't get into that discussion board on OER, um, do feel free to participate and put what you'd like in the chat. But let's try to use the OER discussion board so that we have that to work with from here forward. Okay, so please start by choosing a guiding question and listing that in the discussion board. If you have questions about this process, please throw them into the chat. Okay, so we've had two great webinars so far with Anthony Lacerowitz and Raj Pandya. Our next speaker is Xavier Cortada, along with Adam Roberti from their work in Florida looking at how to engage with art to catalyze adaptation measures to climate change. It's a really cool project called Underwater that they're going to highlight. And we're going to focus on classroom level climate actions for adaptation and mitigation after that talk. And finally, Catherine Hayhoe is going to finish out our series and look at hope and transformative change. We're going to focus on some of our climate mental health resources that help to increase youth agency and foster that hope aspect of the work. I want to mention that there's a lot of ways to connect with Clean. We've got social media. We're glad to do professional development if you have a group that would like us to jump in, and then you can sign up for our newsletter or our network here. Leave that up for just a moment. Joanna, do you want to jump in with thoughts or logistics or anything else here?
Oh, thanks, Patrick. ISKME loves being and OER Commons love being a part of this collaboration. We look forward to seeing you in the group. We want to specifically invite you to start your own thread in the discussion board if you want. And we'll be jumping in to remind you to come back to that discussion board and do a little bit of prep. And if there are other colleagues that you want to bring to our final session, please feel free to do so. A lot of brains are more brilliant and beautiful and iterative than a single brain working on its own. So thank you everyone for attending and participating.